Hello everyone, in this video I'm going to teach you how to solve quadratic equations using completing the square. Before we begin before I give you the examples, let me just tell you that completing the square is like an alternative for quadratic formulas. So meaning you can solve quadratic equations even if the roots are irrational or imaginary or um, it's hard to factorize the quadratic equation. This is an alternative for using quadratic formula. Okay, so let's begin. Let's start with this one. So here we have x squared minus 8x minus 20 equals 0. The first step is I will add 20 on both sides, and then I will have x squared minus 8x plus c equals 20 plus c. Now you notice I put the plus c there because I want to make the trinomial on the left side of this equation as perfect square trinomial. And by the way, for c, the formula of that is b over 2 square. B is the numerical coefficient of the second term. Here it's negative 8. Negative 8 over 2 is negative 4 square, or negative 4 times negative 4 is equal to 16. So this will be x squared minus 8x plus 16 equals 20 plus 16. And then I can factor this out. This is x, and whatever the numerical or whatever the sign of the middle term, that's going to be the sign here. Square root of 16 is equal to 4 square equals 36. And then I'm going to find the square root of both sides. Okay, so this is x minus 4 equals positive negative 6. Then I will add 4 on both sides. So we will be having two possible answers here. The first is 6 plus 4, which is 10. And the second one is negative 6 plus 4, which is equal to negative 2. So I have 10 and negative 2. Okay. Next, let's go to the next example, to the second example. Here we have 2x squared minus 9x minus 5 equals 0. So again, the first step is to add 5 on both sides. This is going to be 2x squared minus 9x equals 5. And if we are completing the square, we want to make sure that our leading term is x squared only. Now here we have 2x squared, so we need to factor out the left side of the equation. So that's 2x squared. So if it's 5, you put the 5 away. You factor out 5, okay? If it's 10, then 10, and so on and so forth. Negative 9 divided by 2 is going to be decimal, but here I'm going to keep it as a fraction. Plus c equals 5 plus 2c. So why is it 2c? Because we have a 2 here outside of x squared minus 9x over 2 plus c, right? So if you multiply 2 and c, that's the one that you're going to put there. C equals b over 2 square. Here it's negative 9. I know it's going to be fraction, right? So the shortcut here is if you have a fraction in the numerator and a whole number in the denominator, you just need to multiply that, and that will be your denominator. Okay, so this is going to be 81 over 16. So 2 times x squared minus 9 over 2x plus 81 over 16 equals 5 plus 2 times 81 over 16. So this is 2 times x minus, again, square root of 81 is 9, square root of 16 is equal to 4. Square equals 5 plus is going to be 8, so that's 81 over 8. Okay, so 81 over 8 plus 5, just cross multiply that. This is going to be 8 times 5 is equal to 40 plus 81 is equal to 121 over 8. I will repeat that. 1 times 8, that's your denominator. 5 times 8 is 40 here. And then 1 times 81 is equal to 81. And 81 plus 40 is equal to 121. and 2 times x minus 9 over 4 squared. And then here, the next step will be divided by both sides by 2, right? So, but if you do that, you're going to have a complex fraction on the right side of the equation. You're going to have 121 over 8 divided by 2. So it's kind of difficult. So what I will do here is I will multiply 1/2 on both sides. It's basically the same. So if I will multiply 1/2 on both sides, that's going to be crossed out. So x minus 9 over 2 squared equals 121 over 16. Next, I'm going to square both sides, cross that out. So it's going to be x, x, what happened? Right, so I will just write here. Oh, there you go. Oh, what's happening? Oh, anyways, x minus 9 over 4 equals 11 over okay, sorry about that. Let me just write x minus 9 over 4 equals 11 over 4. This is positive negative. So I will add 9 over 4 on both sides. So x equals 11 over 4 plus 9 over 4. And then the other one is x equals negative 11 over 4 plus 9 over 4. So here this is 20 over 4, which is equal to 5. And then here we have negative 2 over 4, which is equivalent to negative 1/2. Okay, so there you go. That's the procedure, right? I know that's a lot of work. Okay, let's go to the third example. Here we have 2x squared plus 6x plus 5 equals 0. So minus 5 on both sides. This 2x squared plus 6x equals negative 5. Just like what we did in the previous example, we want the leading term here to be just x squared. So I will factor out that 2 is going to be 3x plus c equals negative 5 plus 2c. Again, that's 2c because of the 2 here outside and the c inside. Okay, so let's solve for c. So 3 over 2 square, right? C is b over 2 square. Okay, so this is 9 over 4. So 2 times x plus 3x plus 9 over 4 equals negative 5 plus 2 times 9 over 4. So 2 times x, so that says this is plus, I'm going to put plus. Square root of 9 is 3, square root of 4 is 2, square equals negative 5. Cross that out, plus 9 over 2. Okay. And then I'm going to put the denominator 1 there, just cross multiply. So 2 times negative 5 is negative 10. And then 1 times 9 is just 9. So negative 10 plus 9 is negative 1 over 2, right? Okay. The next step here is we will get rid of that 2 here. And how we're going to do that, just like what we did in the previous example, I'm going to multiply 1/2 on both sides. Okay, so this is going to be x plus 3 over 2 square equals negative 1 over 4. Okay, and then we will square both sides, or find the square root of both sides. Okay, so cross that out. This is going to be x plus 3 over 2 equals. Now the square root of negative negative 1 is imaginary, it's I, right? But I will write here square root of negative 1 over positive 2. There you go. Okay. So here, let me just remind you that the square root of negative 1 is equal to I. So this is like x minus 3 over 2 on both sides. Okay, let's cross that out. So x equals positive I over 2 minus 3 over 2, which is I minus 3 over 2. And then the next one is here we have negative I over 2 minus 3 over 2, which is equal to negative I minus 3 over 2. There you go. So we have here an imaginary roots. Definitely you cannot factorize that. You can use quadratic formula. We will still come up with the same answer. So if you want to try that, please try that. And by the way, I also have a video about solving quadratic equations using the quadratic formula. So if you want to check that out, please check the video about that. Okay, so let's go to the last example. Let me just double check this. So I got x plus 2 I over 2 minus 3 over 2. Okay, that's right. Okay, let's go to the last example. So 3x squared plus 5x minus 1 equals 0. Let's add 1 on both sides. It's going to be 3x squared plus 5x equals 1, right? So I'm going to factor out 3. This is going to be a fraction again. Okay, so 1 plus 3c. Okay. So to solve for c, that's going to be b over 2 squared. Our b here is 5 over 3 divided by 2, and then square. So that would be 5 over 6. Again, told you the shortcut. If you have a fraction divided by a whole number, just multiply the whole number to the denominator, and that's going to be the answer. Square, that's 25 over 36. So this is 3 times x squared plus 5 over 3x plus 25 over 36 equals 1 plus 3 times 25 over 36. Okay. So 3 times x squared. Oh, no, not x squared. Plus, square root of 25 is 5. Square root of 36 is 6. Square equals 1 plus, it's going to be 12. So 25 over 12. Okay. And then, let's go back there. That's 1 over 1, right? So cross multiply. That's going to be 12. This is going to be 25. Add the 2. This is going to be 37 over 12. 3 times x plus 5 over 6 squared. Okay, next, we want that 3 to be, we will divide both sides by negative 3, but if we will do that, it's going to be like a complex fraction on the right side. So just like what we did in the last 2 examples, I will multiply both sides by 1/3. Okay, so this is going to be x plus 5 over 6 squared equals 37 over 36. And then we will square root both sides. So we will be having x plus 5 over 6 equals square root of 37 over 6. That's positive negative. Then I'm going to subtract 5, 6 on both sides. This is going to be square root of 37 minus 5 over 6. And the other one is negative square root of 37 minus 5 all over 6. So some teachers will tell you that, okay, I will accept that final answer, but some teachers will tell you gotta convert that into decimal. So let's convert that into decimal. It's gonna be square root of 37, okay, minus 5 divided by 6, which is approximately 0.18. And the next one is negative square root of 37 minus 5 is going to be negative 1.85. Okay, so there you go. That's how you solve quadratic equation using completing the square. I know that's a lot of work, and some of you are thinking, oh, I will just prefer quadratic formula. Well, yeah, it really depends on you once you're testing. Like, the question is, what are the roots of this quadratic equation? So you have the freedom, I think, to pick what method are you going to use. But you force, if the teacher, like if it's like a classwork only, then and the teacher tells us to use the completing the square, you got to use the completing the square. Okay, so there you go. That's the video. Thank you for watching. See you in my next video. Have a nice day. Bye bye.